Hi everyone, my name is Sierra. My group members' names are David and Gurleen, and today we will be talking about comets. I hope you guys enjoy our presentation. In our presentation today, we'll be talking about what is a comet, some of the physical features of comets. We kind of added a little bit about comets and meteor showers, and then we'll be discussing comet tails and the difference between plasma and dust tails. And then we'll be talking about the comet orbit versus the Earth's orbit. And then we'll also be including a slide about Halley's Comet, which is just a historical comet that has been seen from Earth. To start off our presentation, we will be talking about what is a comet. So comets come from the Kuiper Belt and the Oort cloud, and they are just frozen leftovers from when the solar system first formed. They are compounds made of dust, rock, and ices, and they can range from a few miles to tens of miles wide. When the object is gravitationally disturbed and flung from the Kuiper belt and into the inner solar system, the ice vaporizes, and that's how it becomes a comet. So as the comet orbits closer to the sun, the compounds heat up and they release gases and dust into a large, vibrant head, which is where, if you see graphics of a comet, that's that burning head. So then that material is released, forms a tail that can stretch millions of miles long, which will be discussed later on. So the physical features of a comet consist of a nucleus, a coma, hydrogen envelope, dust, and plasma tails, or just tails, because there's two different types. We're going to start off with a nucleus, which is a solid core that consists of frozen molecules such as water, carbon monoxide, carbon dioxide, methane, ammonia, and dust. And they typically range from around 10 kilometers across or less. And then the coma is the cloud around the comet that is formed by ice on the surface of the nucleus, which turns into gas. And that happens when the comet gets closer to the sun. The other two features that make up a comet include the hydrogen envelope and the tails. So the hydrogen envelope is made of hydrogen atoms and it surrounds the coma, and they can get up to around 6.2 million miles long, and they get bigger as the comet gets closer to the sun. As for tails, they are shaped by sunlight and solar wind, and I'm not going to go into too much detail because this will be discussed in the next few slides. So an interesting fact to add about comets is that they are the reason that we have meteor showers. So as a comet orbits the sun, small pieces get left along in its path. And so as Earth passes through the path of a comet, those small little pieces create the streaks of light in the night sky, which is called a meteor shower. So I thought that was pretty interesting, so I thought I'd share that.
As comets draw near perihelion, their closest point to the sun, they undergo a transformation. The sun's intense heat can cause the comet's material to vaporize, freeing dust particles once ensnared in the ice. The comet's nucleus experiences the dual influence of solar radiation pressure and the solar wind, leading to the creation of the distinct tails, the ion tail and the dust tail, as gas and dust are swept away. A plasma comet tail refers to the ionized components of the comet's tail. When a comet approaches the sun, the intense heat causes the release of gases from the comet's nucleus. Ultraviolet light from the sun then ionizes these neutral gases, turning them into charged particles or ions. The solar wind, which is a stream of charged particles emitted by the sun, carries these ions away from the comet in a direction opposite to the sun, forming the ion tail. This ionized or plasma tail often appears bluish in color to the ionization process. The plasma tail of a comet is shorter lived than the dust trail due to its direct association with the comet's proximity to the sun. The dust tail of a comet consists of fine particles, usually microscopic in size, that are released from the comet's nucleus as it travels along its orbit. These particles are composed of various materials, including silicate minerals and organic compounds. Unlike the ion tail, which is formed by ionized gases and affected by the solar wind, the dust trail is composed of neutral particles. The dust trail is created because of the comet's interaction with the sun. When a comet approaches the sun, the heat causes sublimation of the ices present in the comet's nucleus, releasing gas and dust into space. The pressure from sunlight, known as solar radiation pressure, then pushes these dust particles away from the comet's nucleus, forming an elongated tail that generally follows the comet's orbital path. The dust trail is often more prominent and longer lasting than the ion tail, and it may appear white or yellowish when viewed from Earth. It provides valuable information on the composition of the comet and the process occurring within.
Next, we will be talking about the difference between a comet's orbit and an Earth's orbit. Before I explain the difference in a comet's orbit versus an Earth's orbit, I would like to explain what an orbit is. An orbit is a continuous path an object makes around another. In this case, how things orbit around Earth and how comets orbit. The objects that orbit around are called satellites, and the shape they go in are called an ellipse, which means oval. An orbital period is the length of time it takes for one orbit. This depends on the object distance and its velocity. Different velocities mean different speeds. Gravity is what keeps the orbit in place. The gravitational pull of the object it's orbiting around is necessary for it to remain in orbit. Lastly, objects can fall out of orbit, which causes them to crash. A lot of satellites fall or crash back to Earth. Comet orbits are usually an ellipse shape. This is due to their close distance to the Sun, but also their distance far into the solar system. The comet's orbit also varies in inclination, which is an angle the orbit is tilted at. The length of orbit is also a wide range for comets. A comet's orbit can take anywhere from years to centuries. There is no exact length. The distance from the Sun, known as the perihelion, for comets can be very small, sometimes within the Earth's orbit, but they also can move far away, known as the aphelion. Comets' orbit can also cause long-tailed comets in the sky due to the close proximity to the Sun, therefore causing the ice composition to vaporize. Now we will be talking about the Earth's orbit. The Earth's shape is almost circular compared to the comet's orbit shape, which is an oval ellipse shape. The Earth's orbit has a very low inclination and is close to the elliptical plane, which is the tilt that is relative to the plane of the solar system. Earth has a steady length for an orbit. An example is Earth's orbit around the Sun, which is 365 days. The Earth's distance from the Sun remains the same, unlike a comet's, which varies.
Halley's Comet, named after the English astronomer Edmund Halley, is renowned for its regular and predictable orbit, returning to the inner solar system approximately every 76 years. One of its most distinctive features is its bright visibility, often making it visible to the naked eye during its rounds. The comet has a nucleus rich in volatile materials, including water ice and organic compounds. As it approaches the Sun, these materials sublimate, releasing gas and forming two distinct tails. Halley's Comet has left a permanent mark in historical records, with documented observations by various cultures throughout history. Notably, the comet has been the subject of space exploration, as the European Space Agency's Giotto spacecraft conducted a close flyby in 1986, providing unprecedented insights into the comet's nucleus. Additionally, Halley's Comet is associated with two meteor showers resulting from Earth's passage through the debris left in the comet's wake. The comet's periodic appearances continue to captivate both astronomers and the public, contributing to its status as one of the most iconic celestial phenomenon.
We hope everyone enjoyed our presentation and learned a little bit of new information about comets, and we just want to say thank you so much for listening.